Before we talk about what makes Saturn terrifying, you need to feel how big it is. Saturn is the second largest planet in our solar system. It has a diameter of roughly 116,000 kilometers. Your brain probably just skipped past that number. Don't let it, because Earth's diameter is about 12,700 kilometers. That means you could line up 9 Earths side by side across Saturn's equator. Or think of it this way. Saturn's volume is so massive that you could fit 764 planet Earths inside it. 764 Earths. Can you imagine now? And yet, here's where it gets genuinely weird. Saturn is the least dense planet in our solar system. In fact, it's the only planet in our solar system that is less dense than water. If you could somehow find a bathtub big enough, Saturn would float, a planet the size of 764 Earths. That floats. Crazy, no? Now, let's talk about the weather. On Earth, when a Category 5 hurricane hits, we call it a catastrophe. We evacuate cities. We mourn the destruction. A Category 5 hurricane has wind speeds of around 250 kilometers per hour. On Saturn, that is a calm Tuesday. Saturn's wind speeds routinely reach 1,800 kilometers per hour. That's not a typo. 1,800 kilometers per hour. These aren't gusts. These aren't temporary surges. These are the baseline conditions on a planet with no solid surface to slow anything down. Just an endless, churning atmosphere that has been accelerating for billions of years. But the winds aren't even the most terrifying part. In 2010 and 2011, astronomers witnessed something extraordinary. A storm erupted in Saturn's northern hemisphere so large, so absurdly large, that it wrapped all the way around the planet. 360 degrees. This storm, called the Great White Spot, was larger than the entire diameter of Earth. It raged for months. It released enough energy to heat the upper atmosphere by 83 degrees Kelvin, detectable from Earth, from billions of kilometers away. And this wasn't even the first time. The Great White Spot appears roughly every 29 years on Saturn, almost like clockwork. Like the planet itself is waking up, remembering it's angry, and deciding to remind the universe. But even that is not the storm we should be most afraid of. For that, we need to go to the North Pole. I mentioned earlier that there's a discovery on Saturn that scientists still can't fully explain. This is it. Sitting at Saturn's North Pole is a storm system unlike anything else we've observed in the solar system. It is not circular. It is not chaotic. It is a perfect hexagon. 6 sides, 6 roughly equal angles. A geometric storm the size of 2 Earths, rotating like clockwork at the top of a gas giant. When Voyager first photographed it in the 1980s, scientists thought it was a camera glitch. It wasn't. Cassini confirmed it decades later and added something even more unsettling. The hexagon has been rotating at the same speed, in the same position, for at least 40 years, possibly much longer. No storm on Earth lasts 40 years. No storm on Earth holds a geometric shape. And the color? When Cassini first arrived in 2004, the hexagon was a deep golden brown. By 2016, it had turned blue. Why? We don't fully know. On a planet we have been studying for centuries. We don't know. Let's say, hypothetically, you decided to visit Saturn. You build the most advanced spacecraft imaginable. You survive the 8 to 10 year journey. You arrive at the outer edge of Saturn's atmosphere. What happens next? First, there's no surface to land on. Saturn is a gas giant. There is no ground. You would simply fall as you descend through the upper atmosphere. You'd encounter clouds of ammonia ice. Beautiful in a way. Then a layer of ammonium hydrosulfide. A compound so corrosive it would eat through most known materials. Below that, water ice and liquid water clouds mixed with chemicals that would be lethal to any known biological organism. Keep falling. The pressure increases exponentially as you go deeper. By the time you reach the lower atmosphere, the pressure would be millions of times greater than Earth's surface pressure. At that depth, the hydrogen that makes up most of Saturn's atmosphere does something extraordinary. It becomes metallic, liquid metallic hydrogen, a state of matter so extreme it barely exists in laboratories on Earth. even for fractions of a second. And that metallic hydrogen? It's likely what generates Saturn's enormous magnetic field, a field 578 times stronger than Earth's. You would not survive a visit to Saturn. Not even close. Now, the rings. The thing that makes Saturn iconic. The thing children draw in school projects. The thing that appears in every space documentary. Here's what they don't show you in the school projects. Saturn's rings span 282,000 kilometers from edge to edge. That is roughly 3/4 of the distance from the Earth to the Moon. And yet, the rings are, on average, only about 10 meters thick. 10 meters. They are proportionally thinner than a sheet of paper compared to their width. Imagine a piece of paper, the size of a football field. That is the dimensional relationship of Saturn's rings. Made up of billions of chunks of ice and rock, ranging from microscopic dust particles to boulders the size of houses, all orbiting at incredible speeds, constantly colliding in a silent, frozen chaos. Beautiful? Yes. But here's the part that should genuinely disturb you. The rings are disappearing. Saturn is literally consuming its own rings. The gravity of the planet is pulling ring material, ice and dust, down into the atmosphere at a rate of tens of thousands of kilograms per second. Scientists now estimate that Saturn's rings could be completely gone within 100 million years. Cosmically speaking, that's tomorrow. And here's the kicker. The rings themselves may only be 100 to 400 million years old. The dinosaurs were walking on Earth before Saturn had its famous rings. The rings were always temporary. We just happened to be alive at exactly the right moment to see them. Saturn doesn't just rule its own domain. It commands an empire of moons. 146 confirmed moons, the most of any planet in the solar system as of our latest count. And several of them are terrifying in their own right. Titan, the largest of Saturn's moons. Larger in fact than the planet Mercury. Titan has a thick atmosphere. The only moon in our solar system that does. It has rivers, lakes, rain, but not water. On Titan, it rains liquid methane. Rivers of methane flow into lakes of liquid methane under an orange, smoggy sky where the sun appears as nothing more than a dim, distant blur. The surface temperature is negative 179 degrees Celsius. A world that looks almost familiar in its geography. Rivers, coastlines, dunes, but would kill you in seconds. Then there's Enceladus, one of the most significant discoveries in modern astronomy. Enceladus is small, only about 500 kilometers across. It should be a frozen dead rock. Instead, from its south pole, Enceladus is actively erupting. Giant geysers, plumes of water vapor and ice, shooting hundreds of kilometers into space. These plumes contain organic molecules, hydrogen, silica particles that indicate hydrothermal vents on the ocean floor beneath its icy crust. In other words, Enceladus has all the ingredients we associate with life. Somewhere beneath the ice of a tiny moon, orbiting Saturn, something might be living. And we have no idea what. And then there's Hyperion, a moon that looks like it was chewed up and spat out by the universe itself. Hyperion is covered in deep, dark craters, so porous, so oddly shaped that it resembles a giant cosmic sponge. But its most unsettling feature? It tumbles. Most moons rotate in predictable, stable patterns, tidally locked to their parent planet. Hyperion has no such loyalty. It rotates in a state of chaotic, unpredictable tumbling. Scientists cannot predict which way it will be oriented at any given time. A moon with no rhythm, no pattern, no order, just chaos. We've talked about the storms, the hexagon, the deadly atmosphere, the dying rings, the strange moons. But I want to leave you with one final thought. In 2017, NASA, as Cassini spacecraft, after 13 years of orbiting Saturn and sending back more data than we could have dreamed, was deliberately crashed into Saturn's atmosphere. Not because it malfunctioned, but because it was running out of fuel. And scientists were afraid. Afraid that if Cassini drifted uncontrolled, it might eventually crash into Enceladus or Titan and contaminate them. contaminate them with Earth bacteria. Think about what that means. We were so convinced that Enceladus and Titan might harbor life, that we killed our own spacecraft to protect whatever might be living there. We sent Cassini on a death dive into the most violent atmosphere in our solar system, as an act of planetary protection. Saturn consumed it in seconds, and the last signal from Cassini reached Earth at the speed of light, 83 minutes after the spacecraft was already gone. For 83 minutes, we didn't know. That is Saturn, a planet so large, so violent, so strange, that the most sophisticated machine humanity ever sent to study it was swallowed whole. And Saturn didn't even notice. Saturn has been orbiting our sun for over 4 billion years, long before Earth had oceans, long before the first cell divided, long before the first human looked up and felt wonder. And it will still be there. Storms raging, rings fading, moons tumbling, long after we're gone. The universe doesn't care about our wonder. But maybe, just maybe, that's exactly why we should keep looking. If this video made you see Saturn differently, hit that like button. It genuinely helps more people find this channel. And if you want to go deeper into the most terrifying, extraordinary places in our universe, subscribe. Because next time, we're going somewhere even darker.